Next one I'll comment on is number 59 off of the chemistry side. Here's the given information. Given 500 mils of a 0.1 molar acid, HNO2, and a 0.15 molar salt, potassium nitrate. The salt is the source of the conjugate base of this acid. We have a buffering system where the capacity of the acid 0.1 molar, capacity of the base 0.15 molar. We're asked in the letter A, if I added 250 milligrams of strong base sodium hydroxide, will I have exceeded the buffering capacity? Well, a strong base sodium hydroxide is going to consume the acid from the buffering. Base will react with acid. What we want to know is, in mole numbers, do we have enough base and acid in terms of capacity? So what I did was to take the sodium hydroxide milligrams and slid the decimal 3 spots. We have to use the unit grams of NaOH. So 250 milligrams is 0.25 grams. I set that over the molar mass of 40, and Na and O and an H adds to 40 for formula weight. And I determined the mole to be 0.0625 moles of NaOH. Looking up here at the information of the acid, 0.1 molar of the acid and the volume of 500 mils, molarity times liter got us the number of moles of acid to be 0.05 moles. Molarity times liter of the information given. So really all I'm being asked is this number, the number of moles of acid, enough to soak up this base, 0.0625? And indeed, I haven't reached its capacity. So 0.0625 is a number smaller than the number of moles of acid. Therefore, I will not exceed the buffering capacity. If I had calculated a larger number of the strong base, 0.05 minus a larger number, it wouldn't make sense, and I have overreached the buffering capacity. They'll all be done that same way. The letter A, B, C, however many parts of the alphabet there might be. There are 4 parts. Keep in mind, part A, part B, you're adding a base, so you want to compare that to the acid. But part C and part D, you're adding acid, so you have to compare that to the base value of 0.15. So a little different chemistry for part C and part D. You're going to check the 0.15 molar times 0.5 liters. The number of moles of base, 0.075 moles, and you have to check that against the amount of acid that you've added. So molarity times volume gets me the number of moles of acid and number of moles of base. Same strategy, take the number they give you. If it's a base, see if you can subtract it from the acid. If it's an acid that they give you, you have to be able to subtract it from the base. NO2 negative ion is the base. As long as it comes out smaller than the number of moles, you have not exceeded the capacity.